So try to stay in your allotted time. Okay? Okay. I think it's about, it's 1:31. I'm late. Okay. Thank you all for coming. It's been a very hectic last couple of weeks. You can kind of tell I'm not aiming to start up a Beatles tribute band. I just haven't had time to get my hair cut, right? So as busy as it's been for the professors, I'm sure it's been crazy busy for the students. So I think this is an exciting time for them to really show off all the great work they did over the semester, and particularly these last few weeks. We have hopefully passed out these assessments metrics for the final presentation. We would like input from the faculty and the board of advisors. The students have hopefully all seen this, so they know this. We would like to welcome our guests here. If we can real quickly, if you're a board of advisors member, if you could simply stand real quick and introduce yourself to the students and who you're from. We'll start with Brian.
Brian Wilson from Duro UAS.
Okay, thank you.
Stephen DeCarlo from Macer Consulting.
Okay.
Richard Mooney, I'm myself, I'm a retired engineer.
And
68.
okay, that's it. I think you all know me. I'm Dr. Brent Warine. We have Dr. Yi Wang here. We both teach sections of this Capstone program. I'm going to just spend another couple of minutes introducing this, mostly for the faculty and our guests. The Capstone program continues to evolve here at Manhattan College, and we continue to experiment a little bit in order to try to improve the program. And I think we have learned a lot in the past as faculty on how to run this program, and we are making some changes, and I'm sure our students will let us know all the changes they think we should make going forward. Some of the things that are unique to this year is that we have kind of reinstituted some small projects that the students go through throughout the year, and throughout this semester, and they lit up an LED. So they had to, go through a design-driven process where they had to interpret the data sheet, interpret the requirements, and then design the circuit. Of course, they've analyzed this type of thing many times, but now they're going through a design process. They go through a similar type of thing with an interrupt processing type application on a microcontroller. And then they also go through, yet again, a similar process on debouncing a switch input. And so we have some technical lectures that have gone on throughout the semester to support that. Intermixed with all that work, we have talked about engineering design processes and how do you, first of all, qualify a project. One of the things we try to do in this course is to we're not expecting the students to, have the next greatest startup or come up with a patentable invention or anything like this, but the project should, as I say, not be a hobby. Okay, so it should have some connection to a market need, at least perceived market need, and so they begin by looking at that. Then they develop requirements to support that, and then they start architecting their system. Dr. Wang and I both work in that general philosophy, but of course we have our individual classes, so you might see a little difference in the groups, and that's reflected in our different choices on how we actually execute our programs. But that's the general approach we've taken this semester. Next semester we will largely return more to a real project development type of thing. They of course started the projects, and then hopefully they will conclude them in May. Well, that's the nice thing about a hard deadline. In industry, sometimes deadlines are hard, sometimes they slip, and you wish they were hard because you end up in this death march where you keep working and working and working, but it never ends. So the students here are fortunate that come May, the project ends, which means that we have very aggressive schedules. So I think anything else I should mention before I go over this here real quick? So what we've done is we've come up with these metrics, and I'll just go through these real quick. Down here is a little scoring sheet, and we've included each of our groups, and then each of the areas that we'd like you to assess. Okay, the assessments run from 1 to 5, where 1 is not so good, and 5 is awesome. Okay, so I've given you some guidelines on how to score that. Of course, we will ultimately end up scaling these and weighting them and all that type of thing. But if you feel that things are adequately covered, the work is pretty good, the presentation has a few stumbles, but that's kind of to be expected of a senior undergrad. You're kind of right there at that 3 level, okay? And you can move either direction accordingly. So real quickly, we'll talk about the quality of the presentation slides. Okay, so one of the things that we do to evaluate our program outcomes is that we want to prepare our students to be able to write well and to present their work well, both in written form and in verbal form. So we're not really a speech class, but we do want the students to have those type of skills. We know that engineers are constantly having to present their work. So are the slides uncluttered? Is graphics favored over text? Avoid unnecessary animations, font size, type, and colors appropriate. These type of things. Hopefully, I think most of the presentations I've seen are in good shape in that area. The quality of the verbal presentation. Is it spoken with confidence and clarity? Are they able to highlight the major points? Okay. The requirements. Now we get into more of the technical area of the work that they have done. Are the requirements well thought out? Are they complete, appropriate to the product and market, clearly presented? Are they specific? Then we look at the system design, including the modules and the interfaces. Is the system clearly described at a level appropriate for a preliminary design review? And that's what the phase that we're at right now is a preliminary design review. They're really supposed to be presenting to their stakeholders to kind of get authorization to move on to a very detailed design phase, right? So, and then, so do the interfaces follow applicable standards, otherwise allow for effective system integration? We want you to evaluate the requirements-driven design. Did the students, are their design decisions traceable back to the requirements and constraints placed on them, okay, on the system, right? So that they didn't just kind of choose a particular design decision out of the air. Is it traceable? Have they properly looked at the risk and analyzed it, have a mitigation plan? They should have, most of them have identified some of their key risks and have already addressed some of those areas, and they're also have some, many of them have some more to do. Have they shown a readiness for the detailed design phase? Here, you're probably going to see a little difference between some of the groups. I'll mention later on that one of our groups is involved in a kind of a unique project that's associated with NASA, and it's a very large $100,000 grant that we submitted in November, and we won't know whether we get or not. If we don't get it, then unless one of our board of advisors Advisors, which is to donate $100,000 to the cause, they have to kind of scramble and come up with a new project. So theirs is a little unique. You'll see some differences in this area. So we certainly understand that. And then also the response to questions. Okay, so students are prepared to answer questions. Hopefully they're prepared to answer questions. So any questions from the faculty or Board of Advisors on that? And if not, let's see, we have a schedule, and I'm going to turn it over to TCM, Shades. Is that your name? TCM?
Yeah, same rough on it.
Okay, come on up.
Hello, everybody. Thank you all for coming. My name is Chris Suarez,
And I'm Nick Christensen,
and we are SK Engineering.
and we're here today to talk to you about our product, which is called TCM Shades. Okay.
So did you plug in the touch drive? Is it on?
Oh,
It's just a minute. It will work.
yeah, probably have to get a little closer.
And that stands for temperature-controlled motorized shades. And here's a picture of our logo.
So, with this project, we intend to bring home automation, which is seen as complex and high in cost, to households everywhere by offering a simple, reliable, and economically friendly device which automatically adjusts window shades. So who are we?
So I'm Chris Suarez. I am a senior electrical engineer with hopefully a math minor at the end of the semester. I serve as co-designer, project engineer, a project manager, lead software engineer, and integrations engineer. So I'll be working on making the control algorithm for the most part.
My name is Nick Christensen. I am also a senior electrical engineer with hopefully a math minor. Along with Chris, I am the co-designer for this project, and I am the primary tester, lead hardware engineer, and mechanics engineer. So I'll be taking care of a lot of the hardware, like the electronic circuit and the motors. So, our market context. Home automation is becoming more popular daily. We see many more homeowners becoming more amenable to electrical automated systems in their homes. However, we noticed a few key issues when attempting to step into this market with a new product. Chris is going to talk about those.
Home automation is seen as a non-mainstream market. This is due to the apparent complexity with the simple electrical systems to an unseasoned user. In addition, solar panel technology is also still increasing in development. They are expensive. These panels are expensive. It is due to these costs that we would not install such systems on every window of your home. But we will not be installing our system on every window. Only southward-facing windows where solar intensity can be maximized entirely. Lastly, homeowners that are intimidated by this product, we designed our product with this fear in mind. So this way, you'll be less apprehensive when approaching it, and then you can purchase it very easily and install it easily. It is a simple, non-intrusive way to get into home automation.
We've laid out 5 major requirements that we want to consider when designing our product. Number 1, we want it to be safe. If you want to install this product on general market household homeowners on most windows in their home, can't have it bursting into flames when it tries to run. That would be bad. Safety is our top priority when designing this product. We also want it to be simple. Like Chris said, many homeowners are scared off by home automation processes. We want this system to feel like it belongs in your home as much as your heating and air conditioning systems. We want it to be self-sustaining. The main draw for this product is that it's going to be powered completely by the solar panel. It's got a backup battery just in case stuff goes wrong, trees, weather, but the solar panel is really what we want this product to display. We're designing our system to be responsive to plus or minus about 1 degree Celsius. We feel that's a good range to adjust shades if the temperature inside the room is off by about that much. And finally, we want it to be minimal maintenance. We don't want the user to ever have to worry about the mechanical or electrical systems once it's been installed. It should feel like a normal, non-mechanized set of shades that does additional things for you. Now, I'm sure you want to see some pictures, so Chris is going to talk about our top-tier design.
So the focal point of our design is having 2 rows of solar shades. we'll go into that later, why we have two. The solar panel will be mounted on the inside of the window, and the solar radiation will act as a trigger for our sensory network. All of our electrical and mechanical components will be in the control box, which will attach the two independent DC motors to the shades, to their shafts directly. So, and that's really the entirety of the design.
So here's a really, really simple picture of our hardware layout. The microcontroller circuit is going to be the primary subsystem. It's going to contain the algorithm that's going to adjust the shades. As I said before, the solar panel array is really important. It's going to power the whole system. It's going to deliver the power to the microcontroller circuit, which is going to then spread out the power to all the other subsystems. The hardware circuit contains a thermocouple, which converts ambient heat into voltage, and a photocell, which is a variable resistor that changes its resistance based on how much incident light is shown upon it. We're going to use these two parts in conjunction to generate a voltage that's going to be read by the microcontroller circuit. The circuit's going to have an algorithm in it that decides, that compares to a reference temperature that the user can input for what they want inside the room. And if it decides that it's more than 1 degree Celsius away, it's going to adjust these motors by sending a signal to them to adjust up or down to try to match the temperature.
So for the components and subsystems, the solar shades can be made out of a couple different materials. The materials, we have a slide dedicated to that, which we'll show you. And for the software, the chip we're going to use is an AT Mega 328, which is commonly used in Arduino platforming, and that's used for autonomous implementations usually. It runs off C++ with its own libraries, and it is in that software that I will be creating our control algorithm to control the shades.
The solar panel, again, critical part of the design. We're going to make sure we choose that so that it's able to deliver enough power to power the whole system. The hardware consists basically only of the thermocouple and photocell. It's going to have a couple current limiting resistors maybe, if the parts require a lower amount of current or voltage to run properly. And for the motors, we're going to use two identical small DC motors to control the shafts of the shades. We need them to be small enough to fit in the little control box so that it's unobtrusive, and small enough to run off of the amount of power that the solar panel is going to give us. But it also needs to have enough output torque to spin the shades. Now we found a small DC motor online. Very, very basic. It was just a quick Google search. This is the first thing that came up, but it works really well. I included the data sheet for it at the bottom. So after some small calculations, we found that the average weight of a roll of solar shades is about 1 to 2 pounds, which is about 5 newtons. A quick formula here shows that the amount of torque that is required by a motor to adjust these shades is about 3.75 millinewton meters. However, at full load, this motor can only support 0.63 millinewton meters. So we have to, if we were dead set on using this motor, we would have to use a gear ratio to scale the torque by a factor of 6. So a 1 to 6 gear ratio. This would scale the speed of the motor down by a factor of 6, but that's okay because we don't need this motor spinning at 6,600 RPM. That would probably be bad. So we'd be okay with that. But, yes. But what's most likely going to happen is with more research, Chris and I will find a better DC motor with a higher output torque so we can eliminate the need for gears entirely from the system, which would be great.
So for the shades, solar shades can be made out of a few different materials. It's light color, dark color, or high performance material. The high performance material is designed to outclass and outperform the light and dark materials entirely with regards to heat and optical qualities. The reason for having two rolls of shades is because the qualities have to do with the optical and thermal classifications. Can be really good under certain conditions, for instance, the spring and the summer, but those qualities in other times can downgrade performance. By having individual roles, we can focus on the better qualities of each without having to adhere to the cons of those qualities. For instance, if we want a high openness factor, this will allow more light into the room and be able to see out more. However, during the night, this will cause problems with privacy. We plan to also prevent that from happening by having both rolls deployed at the same time at night, and this will give you the same privacy normal speeds would have.
So here are the standards we've identified for this project so far. The ANSI Admiral 1012 standard talks about gears and gear ratios. We may have to consider that if we do end up needing a gear ratio. ANSI NEMA MG1 talks about all different kinds of motors, and we'll be adhering to its DC motor standards for our implementation and testing. ASTM E22013 talks about thermocouples, and IECTS 61836 talks about photocells. And we're going to have to follow both of those. They outline a good amount of testing for the hardware circuit that we're going to use. We're programming the microcontroller with C++, which is by that standard's there. And when we finalize the design for our hardware and motor circuits, we hope to make a printed circuit board. We're going to order that, and that's where the I2C bus specifications come in. And all of our measurements will be taken and recorded in the metric system.
So our project is relatively low risk. As long as we do what we're supposed to do and design it how we outlined here, there won't be any problem with coordinating that and integrating all the parts together.
Everything should run just fine. The main risk we might run into is that we're planning on 3D printing a lot of the mechanical parts like the gears and the shafts of the shades. I'm going to be looking into the Manhattan College 3D printer to see if we can get access to that, and that should take care of all of our mechanical issues as long as we get that coordinated properly.
So the control box, which we outlined in the top tier design, which will houses all of our main parts, will be also 3D printed. So for form and fitting, everything is going to get installed the way we need it to be. The only downside to that is if it starts to get too big, it starts to dig into the overall aesthetics of the design. So our main thing when we do is graduate. that's our plan next semester. But
In all seriousness, our real plan next semester is we're going to immediately finalize, and still want to graduate. We're going to finalize our hardware, motor circuit, and solar panels. We're going to have the design completely finished by the time we get back to school. And we also have to finalize our design on the embedded computer, planning on using the Atmel chip from the Arduino design to design our own custom Arduino circuit to suit our needs, rather than rely on the generic one.
So fortunately, me and Nick are working for the same company over the winter. So during that time, we plan to finalize the design and buy the parts. And so this way, when we come into the next semester, we can go right into design the software and integrating the hardware.
That wraps up our presentation, so I'd like to open the floor to questions for any time remaining. Yes.
So have you given thought to the general appearance of this? I mean, the idea sounds fantastic,
Yeah.
but I think about a little controller box, and I think about a solar panel, and I think about my wife saying that thing's disgusting.
So we actually would like to plan to have the solar panel as high up as possible. So the shades will usually always be behind the solar panel, so you won't even see the solar panel for the most part, ideally.
Should be high up on the window.
Yeah.
Behind the shades.
We didn't do that in the top tier design because then you wouldn't see the solar panel. Additionally,
Yeah, we're planning on making the control box as small as possible, and it should be, and it's actually lucky we're doing it in this room, near the top of these shades, where the hinges are and where it's supported to the wall, is where the control box is going to be. It should be up high enough that it's not really visible or a problem. Dr. Capstone, you have a question?
Yeah, have you guys thought about including a personalized override where a person just says, I don't like what this is doing, I just want this up or this down? Can you
Yes.
include that in your design?
We intend to have actually a remote which is controlled through infrared. We didn't post much of that here because that's still in development and we're still looking at that, looking into that. We didn't have as much facts about that and we haven't really looked into it too much. So it's going to be probably in the next review. We'll have more about
I mean,
our
practically, I would imagine that would be a very serious
Yeah,
practical consideration for people to accept this product.
right. We intended the remote to have a small screen on it which will have all the inputs and you can control it easily with like 2 buttons and input your data. It'll be fairly easy to control and
Yeah, even simpler than this, just an up and down button and a small screen to show you what the temperature is.
right.
One more short question. You guys have any concerns regarding heat for your microprocessor being up in the front where the sun's coming through for any of your electronics?
Yeah, we did look into that. The chip is pretty durable. It's used on an Arduino platform. There is some documentation and examples of it being in such situations. and we believe that it will still perform to how we need it to be. Yes,
And we'll include any slots or vents in the box if you need to.
correct.
Okay, I
What
think
cost,
we-
what cost price are you looking for? The cost, how much for you going to
Oh,
cost?
Price point.
We predict possibly that it could be maybe 150
Yeah, definitely a low retail price. Our budget is, we're well within the budget for now.
for initial cost, and then once we can probably even get it down if we start getting, if it was mass produced.
Try to include in your report also cost.
I'm sorry?
Cost of
Try to include cost evaluation into your report. In
Yes,
your report,
yeah, in the
include
next
cost,
presentation, we're
yes.
gonna have cost evaluation.
Thank you.
Yeah, it's actually in our report too. I don't know.
The students have much more information in their reports. And unfortunately, to accommodate all the groups today, we had to limit the presentations.
Okay.
And that was one of the,
We do have
some of the
more
students.
cost
will have
analysis
that.
in the report.
Yeah, we'll send out the report to everyone at some point if we haven't already.
Thank you.
Okay, and if we can do a quick transition, we might have room for one more question.
What about installation? Have you guys thought of that? I mean, is it like a
Right.
easy instruction manual where somebody's like, cool, I got my shades,
That's-
wire.
That's
hook up?
certainly the idea. I know I thought of it, if say it was a person living on their own, how would they be able to get up on a chair and install this themselves? We intend to have, but that's not going to be the case. You will need another person probably to install it.
But people have to do that anyway when they're installing their own shades. You still gotta screw them in
Right.
and change the.
Our intention is it to be easy installation of the rolls, and then lock them in place, and then getting up and then screwing them down, and then being pretty easy and unintrusive to your home.
And we thought we'd manufacture the box with holes in the back that you just mount on screws. If you
Yeah,
want.
yes.
Very, very simple and intrusive.
I just had a recommendation.
Yes.
In the unlikely event that your system fails, you should have a way to override that, where you can just manually make it work. Because you don't want to be in a situation where it fails in the down position.
Yeah.
You can't change it.
That's a good point.
These?